Through this presentation, I would like to walk you through the DevOps pipeline we created for two applications. The first one was an app called Checkbox, and through this we could host surveys. It was Node.js based and required MongoDB and Nginx. The second one, called iTrust, was to keep track of users' medical records. It was Java based and required Maven, SQL, and Tomcat. Our DevOps pipeline consists of a build stage, test and analysis stage, and finally deploy to production stage. And towards the end, I would speak about the special milestone which we achieved. In the build stage, we automated the creation of a Jenkins server and assignments of Jenkins job to enable the local build of both the apps. Ansible was a config management tool we used, and we also leveraged certain Jenkins plugins. Post build success, the app is locally deployed to Vagrant VMs. Now, this is a high-level diagram of the build task and what I just explained. And this is a snip of the Jenkins server, the build logs, and both the applications. Now, in the test and analysis stage, consider a developer checking in code and test cases for the code. We created a fuzzer that would fuzz his code and run the test cases against it. If the test cases pass, then it does not work, and we created a tool that determined these useless test cases. We implemented it for just the iTrust app. Now, for the analysis component, we analyzed the code coverage using the Jenkins Jacoco plugin, and we also put certain constraints for the code, and this could be considered as a code review process, such as if any method has a complexity greater than 3, if there are more than 120 lines in any method, or if there's message chaining greater than 3. And if these constraints are encountered within the code, the build would fail. So this is the build failing when the constraints are encountered. This is the fuzzing and the detection of useless test cases. And finally, this is the code coverage using the Jacoco plugin. Now, in the deployment stage, we automated the deployment to a production EC2 instances. We also created a Nomad cluster and ran a Nomad job on one of the worker nodes. And in case that worker node fails, we give the job over to the other worker node. We also implemented a feature flag using a Redis master-slave architecture. Finally, we did a canary release, that is, certain percent of the traffic was sent to a stable version in the prod, and the remaining was sent to the not so stable version. And this was implemented using a load balancer. The underlying logic of the load balancer depends on the Redis database, which has IPs of all the instances tagged stable and non-stable. And finally, we also executed a rolling update where we did a serial rolling update on all EC2 instances with a newer version of the code. All the tasks that I have mentioned till now were carried out completely in an automated fashion using Ansible Playbook, Bash scripts, and Jenkins plugins. Now, moving on to the final special milestone, I would like to shift the focus now over to the customer who would use a DevOps pipeline to deploy the application to the prod, that is a cloud. But before they do that, they need to be aware of various factors of the application that might inhibit their move to the cloud. These factors would result in ineffective utilization of cloud resources, and essentially they would not see any edge over their competitors and not gain much profit. And also, the final results that we produce might help them refactor the application and maybe even choose the right cloud provider. So we analyze various aspects of the application, such as the compute, network, storage, compliance, security, licensing, dependencies, and the overall architecture of the application. How we implemented it was we ask a series of questions based on every aspect, and we assign certain scores, and based on these scores we classify the application, and this is all in the backend, and we email the final result to the user. Thank you so much, and we are now open for questions.